Uh, Good morning, everyone, and welcome to this webinar on decision-making tools for sustainable forestry. My name is Luigi Saulino. I'm from the Department of Agricultural Science at University of Naples, Federico II. So here I'm the coordinator of the project, and today I will guide you through an overview of the DigiMedFor, a project funded by the European Union to promote innovation in the Mediterranean forest management. So let's begin by looking at what this project is about and why it's so relevant today. The project is funded under the Horizon Europe program, specifically the Harnessing the Digital Revolution in the Forest-Based Sector call, and it falls under the Horizon Innovation Action. The project started on 1st June of 2023 and ran for 36 months. Now we are approaching the end of the project. This shows also the strong commitment at European level to support digital transformation in the forestry sector. DigiMedFor is carried out by a large and diverse consortium. So in total, we have 21 beneficiaries from 11 countries, representing a research institution, university, there is a company, and also in general forest-related organizations. Here you see a first group of partners from Italy, Spain, Finland, Belgium, and Greece. This geographical diversity ensures that the project covers the variety of forest environments and also supply chain contexts typical of the Mediterranean and European landscapes. Here is the second group of beneficiaries coming from Spain, France, Croatia, Slovakia, Turkey, Tunisia, and Ukraine. This mix of European and also ex-European Mediterranean partners increase the project potential impact across the entire Mediterranean region. It also reinforces opportunity for knowledge exchange, innovation transfer, and long-term collaboration in sustainable forestry. Mediterranean forests present both opportunity and challenges across the forest wood and non-wood supply chain. So that we identify three main sectors that can greatly benefit from digital solution. One is forest monitoring and inventory system. The second one is related to the wood and traceability and grading of wood resource and products. And the last one is decision-making process for forest planning. This represents the backbone of innovation roadmap and guide the development of all activities of the project. Digital technologies also offer a unique opportunity to bridge the gap between forest stakeholders and digital experts. Our approach focuses on three major processes: increasing the number of inventoried forests through an harmonized data collection at local scale, cope with illegal wood logging by improving certification and traceability tools, and also optimizing the decision-making, the forest wood supply chain through a new knowledge-based management system. So in short, with this project, we are building both technological tools and also the condition for their adoption. The project is structured in 7 work packages, each led by different consortium members. Department of Agricultural Science is a coordinator of work package 1 and also on work page 4 on decision support system. CERT led the digitalization in forests, while CNR led grading and traceability of wood, while DBL oversee all the demonstrations with the end user, pedal the sustainability and uptake, while LR led the stakeholders engagement and dissemination of the project. So this structure ensures current progress from technology development to testing and also adoption. Within the project, we had the opportunity to establish 4 pilot sites spread across Italy, Greece, Spain, each focused on a specific challenges. In Italy, a model forest in Italy with spread wood qualification, tagging, and traceability. While in Greece, we combine ground-based and remote sensing for improved forest inventory. While with CESEFOR, we work on the monitoring, traceability of forests with the cargo transport, and with CREAF assessment of the ecosystem services with digital tools. This pilot allow us to test technology in real operational conditions. In addition to pilots, we have 5 replication sites, one in Croatia, in France, in Tunisia, in Turkey, and Ukraine. This site allow us also to test the adoption of our solution for different ecosystem and forest management frameworks. They also support early adoption beyond the core of pilot areas. To conclude, DigiMedFor aims to modernize Mediterranean forest management by integrating advanced digital tools through the forest food supply chain. Our goal is to promote sustainability, transparency, and efficiency while supporting local stakeholders and valorizing also forest resources. Thank you for your attention. For more information, I suggest you to visit our website. And now, so I will be happy to give the floor to the next speakers.
Thank you, Luigi. Okay, I will share my screen. Can you see my screen?
Not yet. Now, yes.
Perfect. Okay. Good morning, everybody. This is Valerio Minopoli, XR Product Manager at Mare Group, which is one of the partners of the DigiMedFor project. I'm also project manager for this project at Mare Group. And today, I'd like to guide you through an overview of what we are developing within the project, which is the Virtual Forest Decision Support System as a decision-making tool for sustainable forestry. In particular, I will provide you with an overview of the system we are developing. I will show you the main feature of the system, so how it can be used as a decision-making tool. How we apply the technology to the first pilot in Italy, what we have learned from the application of the technology to the pilot and the feedback we got, and also what's in the future for the system. So what are the next steps of the tool? Well, first of all, I would like to start with the fact that this tool is under development within the work package 4 of the project, and it is expected to be delivered at the end of this month after a 2-month extension. So what you are going to see today is just a demo version of the whole system, but it can provide you with a good insight of what you will see when the deliverable is completed. So what are we talking about? The Virtual Forest Decision Support System is an immersive digital twin system that helps users explore, simulate, and understand which are the best forest management strategies to apply to a real plot. And that lets you save money and time, most of all, in order to accomplish that. How is it that possible? Well, the system is a digital twin, so we are replicating a real forest in a virtual environment. that you can use with the VR headset, so virtual reality headset. And there are a few tools you can use to perform forest management strategies, and you can predict the results in a very few minutes instead of years and years. In fact, today users must use literacy, and so they must read the history of all the techniques used and strategy used to have an idea of what the outcomes can be. But with this tool, you can decide to apply one strategy over another and can see the results in a very few minutes. The system is intended to be used by the public administration, the government services that are in charge of the management of all the public forests. It is for forest managers and technicians, but it's also useful for researchers, especially from the scientific community, but can be also used by citizens or forest owners by the rural communities. So it is a tool that can be used by very different role players. Well, what are the main features of the system? We had to start from the concept of digital twin. So our idea is if we want precise results, we must start with something which is close to reality. And the digital twin is intended as a tool to replicate real forest in a virtual environment. So as you can see from the videos, we started from the creation of 3D models of trees that must be very close to the real ones. In order to accomplish that, we have some preset. So that means that the 3D trees are editable and they can be adapted to the real trees thanks to some data that are from the inventories. So for each forest, we already have the data regarding the position of each tree, the size, the height, the crown dimension, the diameter of the tree, and we can adapt these parameters to each tree so that we can replicate the vegetation of a site. Then the next step is to replicate the site, especially the landscape. So we started with the development of a tool that lets you define an area, which is georeferentiated. So you can put the latitude, the longitude of an area and create the exact same area. And thanks to some data available online, like from Google Earth, we can also replicate the characteristics of the landscape, such as the slope, which is also relevant when you want to create a digital twin. So here you can see at the end of the video an example of the workflow behind the creation of the digital twin and the fact that you can see a forest, a virtual forest, which is close to the real one. So the realism is highly similar, but it's not perfectly similar to the real forest. But this is at least enough to perform the techniques we want to perform. The next step to have a digital twin is to set the right parameters in the simulation. Given that we want to simulate the growth of a forest, the most relevant factor is the light. So the system let users decide the date and the time of the day, and accordingly it changes the amount of light in the scene, so that the forest is affected by the amount of light, and the simulation of the growth of the forest is highly accurate. Once the digital twin is developed, then we had to think of the users, and we thought about the possible fruition of the system. So the virtual reality is a very highly impact technology, but it's not the best solution for any use case. So the system is intended to work with two modes. One is the VR mode, and the other one is desktop mode. So that for very specific action, users can decide to go into the forest, explore the environment, and pick, for example, a tree that they want to perform something on. While to have a big picture of the forest, they can use the desktop version. But what are the take in action features of the system? Well, the system let users plant or cut trees so that they can perform forest management techniques. And this is a highly accurate action so that you can pick a tree one by one and decide to cut each tree, or you can select a bunch of trees according to some criteria. In order to have a clear picture of what you are doing, the system guides you thanks to some statistics. So you can see the amount of biomass you are cutting, for example, or if you want to cut specific trees above a certain height, you can do that. And this is calculated before the cutting and after the cutting. So you can have a preview of what you are doing and what the results will be. And thanks to the integration with a mathematical model developed by the University of Naples, Federico II, the system will also simulate the growth of the forest so that in a few minutes you can skip in time, you can go forward in time, and you can have the result of the growth of the forest in a very few minutes instead of waiting years and years in reality. I would like to show you the application of the system as it is right now, so not the final version, to the pilot forest in Vallombrosa, which is in Tuscany near Florence. You can see here two videos of the location of the site on the left, and on the right is a video taken on the site. So these are the real trees in the Vallombrosa forest. And from pictures and data online, we use the tool to replicate this landscape. And here you can navigate the virtual landscape. The trees are placed in the same exact spot of the real ones. In this case, we have only one species, which is the Douglas fir. But these 3D models of the trees replicate the exact real trees by gathering parameters like the size of the trees and the position. So this is the idea of digital twin inside this decision support system. Coming back to the features, I can show you right now the desktop mode of the system. You can see some trees, and on the right, you can decide the amount of years you want to skip, and you can see that the trees change accordingly. So they are growing, or you can go back in time and check how they were before the action. Or you can select an area, so you can choose which tree you want to perform a technique, a forest management technique. And you can later decide if you want to cut them or if you want to pick some of these trees according to the criteria you prefer and perform the activity. So here you can see, I'm sorry that the stats are in Italian, but it's just a preview of the system. What about the VR mode? So here's a video taken from the virtual reality headset. So users can be in the digital twin of the forest. They can see each tree one by one, and they can perform basic actions like getting information from a tree, or deciding to cut one of them at a time, or even if they want to plant a new one. And the benefit of the system is that every action taken in VR then affects the outcome of the simulation. So if you want to predict the result of the growth of the forest after cutting 3 or 4 trees, you can do that. Thanks to the application of the technology to this pilot site, we were able to understand that the system is scalable and we have the potential to replicate the system to different forests. So we are now starting within the project with 4 forests, but it can be applied to any kind of forest as long as we have all the data we need for the trees and for the slope of the landscape. The decision support needs clarity. That means that at the moment you can see stats of selecting some trees, but what is fundamental to the people involved, to the users involved in this project is that you must get a preview of what is going to be the forest after taking an action. So if I cut some of the trees, I want to understand what are the stats, what are the parameters I'm changing before taking action. The 2 modes of fruition are great for the users because the use cases are different. So in some forests, you can decide to act on each tree individually, and the VR is great for that. But in other cases, you need to work on more trees at once. So the desktop mode is very efficient in that case. Another takeaway is that the collaboration with domain experts is fundamental because the realism degree for the simulation must be very high in order to let users understand what they are doing within the simulation, what they are doing in the virtual environment, and to be fully living the experience instead of just using a tool. What are the next steps for the system? Well, we are now working on the addition of the other 3 sites to apply the technology. We are still integrating the mathematical model developed by UNINA to make it fully work with the digital twin. We are now deciding which data are more useful for the users to understand what they are working on. And finally, we are also deciding which are the most common criteria users utilize to perform their action when they cut trees or when they plant new ones. So thank you for your attention, and I hope that you enjoyed this session. Thank you.
Thank you, Valerio. I think I'll share my screen now for the next part. I think there's a Q&A session after this, so everyone can have some questions regarding what Valerio spoke or regarding my presentation, which is coming up. So everyone can see my screen now?
Yes,
Yep.
yes.
Okay, perfect. So good morning, everyone. My name is Antonio De Marco from CESEFOR, partner of the DigiMedFor project. And in the next 10 minutes, I'll show you how we go from forest data acquisition to decision support, and finally to evidence-based traceability from forest to industry. So this is a general overview of the presentation. I'm gonna try to keep this very practical. First, give the context on the pilot side. Then I'm gonna talk about the workflow, and then a short dive into each of the tools that we have developed or that we have tested. Then I'm gonna close with some lessons learned and the stakeholder value. So let's start with the problem we're solving. In forestry to industry operations, right now, there are constantly 3 needs, we could say. We need reliable inventories, we need enforceable traceability, and we need better decisions under different changes. In real operations, what happens is that gaps appear. and gaps appear between what is planned and what is actually delivered. So that uncertainty is what gets us into planning errors, disputes, and usually lower trust across the chain, the workflow. Okay. So in DigiMedFor, we are going to try, or we tried to test the full digital chain designed to reduce those gaps. First off, I'm going to talk about our pilot site. It's the Urbion model forest, around 180,000 hectares, with roughly around 4,000 hectares auctioned and harvested every year. This matters because the workflow is tested under a real market and operational conditions. We have contracts, we have logistics, and we have compliance. So it's not just a laboratory; it's what happens in real life. And this brings us to also the key stakeholders that we have in this area. We have forest owners, we have managers, we have harvesting contractors, carriers, sawmills, and also very importantly, public administrations, because we can also talk in between the industry and the public administration, which is really, really helpful for them. So with that context, here's the workflow as one continuous chain. I try to gather all the technologies that we have used into one single workflow because there is some input-output relation between them. So first, we measure. In our case, we use drone inventory digitalization. So we start from a precise baseline with a really high quality data sets from the forests that we're managing. Then we manage, then we translate, which is the DKP, the DigiMedFor knowledge platform, which combines a data repository and the forest pathway, which I'm going to talk later, okay? After that, we simulate and communicate, which is something that already Valerio has talked about, which is the virtual forest decision support system, where we make trade-offs understandable and support engagement, and we also get stakeholders to understand what is happening in the management process. And lastly, we execute and verify, which is one of the developments that we have done from CESEFOR, which we presented in a webinar some weeks ago, and that is the picture-based tracking system, which is based in Nemus, the website, and Tracker, the mobile site. So yeah, let's start from the beginning. By the way, anyone viewing this webinar right now can get their phones out and check the QR code on the top right to get linked to a sample of a data set that we captured recently using this technology, okay, in case anyone is interested. This system is based in using under canopy flights and over canopy flights using drones. They're not the same type of drones. Ones are more suitable for under canopy, and the other ones are usual lighter drones. So here in our pilot area, we flew around 200 hectares, but we also went into a regional scale and flew around some more areas around Castilla y León due to spatial stakeholder interest in this technology. The outputs are very variable, but they're really high detailed outputs. We have georeferenced imagery, we have terrain canopy products, individual tree metrics that we can get in a GIS, and we have also indicators that are really useful for planning in different parts of the stakeholder workflow. So, as I said at the start, what we wanted to do is that we want to reduce the unknown starting point. So this is what we need. We need really high quality data before we decide what to do. Okay. Once we have the data, what do? We need to translate it into actionable guidance. And this is where the DKP comes in. Okay. The DKP, the DigiMedFor knowledge platform, is based in two parts. Okay. We could say there's two tools inside this tool. Okay. The DKP has a repository layer, which is based on Zenodo. We just have quite a bit of data sets right now from different partners around the whole DigiMedFor partnership. We appreciate, by the way, the efforts by other project partners to comply and to give a lot of their data sets and put them into an open state for the rest of the people to be able to see them. But we also have the forest pathway. The forest pathway is just a step-by-step management itinerary and scenario reasoning related to silvicultural practices that we could do in a forest at a certain moment. It's like a bank configurator or a assurance configurator, we could say, but in terms of forestry management. Okay, so in our pilot, it's really important. What I think it's really important the job that was done here, because we unlocked high regional data, which are integrated right now in something we call the silvicultural technical references from Castilla y León. And also these references were changed really recently, like in December 2025, to comply with one of our national governance laws, which is our royal decree. And what we did is to transform that dense structure of a lot of data, a lot of documents, into an intuitive configurator, something that is useful for people that just want to know what they have now, and they want to know what type of management they need to do to reach a certain point. Okay. So what we did is just try to get legal and sustainable models to become easier to apply in practice as a whole. Okay. You can also access the DKP here by using this link on the top right, okay, if anyone is interested. But everything is also directly linked in the DigiMedFor website. So now that we have the options, now we need to have at least we need to see how these management options affect what we have. And this is where the tool Valerio was talking about comes into place, okay? This is really important for us because what we did is get different stakeholders to try this technology and to try this interface. Initially, it's quite difficult for some people, but there's some other people which are, once they start getting used to it, they have a lot of good positive feedback, because they don't need to go to the place and need to see in like by their own eyes how the management is going to be done. And they can simulate a lot of situations which you can't usually do when you are directly in the place that you're studying. So this is really important for engagement, training, and communication with stakeholders. Okay, and as Valerio already talked about this, I'm gonna go to the next slide, which is once the decisions are already made with our DKP, with the Victor Forest decision system, then we go to the execution. We go to the picture-based tracking system. Okay. This is two parts of the picture-based tracking system. We have Nemus and we have Tracker. Nemus is the website of the tool, and Tracker is the mobile part of the tool. Okay, Nemus is a web platform which is used to create and manage lots of industry that want to extract timber from some places. And Tracker is the mobile app which guides the driver through the operational phases and captures photos with geolocalization. There's another webinar 2 weeks before this one, which already, or 2 or 3 weeks, I don't remember right now, which explains this tool in detail. Okay, if anyone is interested in getting into it, there's probably the webinars. The recording is probably in the DigiMedFor homepage. Okay, so I'm gonna also step here. I'm going to focus in the feedback and the lessons learned. The feedback and the lessons learned here are really important because it hasn't been a lab. It hasn't been a laboratory experience. It has been a real experience. We have seen a lot of adoption constraints, initially because of cost sensitivity, especially with inventory, and also some tools are quite cost. I mean, that they have a high cost for certain stakeholders. So that's the first part, which is important that we need to tackle into some way from when the DigiMedFor project ends. But also there's other parts. There's training needs. There's also rural connectivity. There's a lot of issues that usually we face when we go into the real world with these tools. Okay, but on the right side, on the good side, the traceability part is really perceived as something immediately valuable. Everyone that has been presented with the tools of traceability has seen a really good tool to be used in their day-to-day. Initially, I mean, the most important stakeholder is usually in the industry, but also the public administration has been really interested in this. And lastly, the DKP, the DigiMedFor Knowledge Platform. Some stakeholders want pathways, some stakeholders want recommended steps, Others want processed indicators related to their data sets. So the DigiMedFor knowledge platform is just like the start of something that in the future we could probably evolve into something that is more appealing for certain stakeholders that right now maybe is not. So that is probably our feedback for this part. And as stakeholder value, which is the last slide, we have different parts. For forest owners and managers, the value is better starting point and clear interventions. The contractors and the carriers have streamlined operations and fewer disputes. Sawmills and industry, it's delivery evidence and volume validation. For public administration, it's a stronger control through the indicators, through data that they have to prove what is happening in their forests. For research and consultancy, it's access to data sets and transparent assumptions. And as a whole, the real impact appears when the chain works as a system. That's what we understood. We measure, we decide, we communicate, and then we verify. So behind all this, I wanted to ask you an open question. Where do you think you fit in this workflow? And if you think you sit somewhere in between, some tools are useful for you. If your priority is planning and accuracy, start from the measurement or the DKP. If your priority is operational controls and trust, tracking provides immediate value with the picture-based tracking system. And if you need stakeholder alignment, the VFDSS is probably a tool that is useful for you. So feel free to reach out via digimedfor.eu, CESEFOR.com, or email me at antonio.demarco@cesefor.com if you have any questions or you want to ask for any more information regarding any of these technologies. Okay, thank you very much.
Thank you very much for this presentation, and to the speakers, Luigi, Valerio, and Antonio. It was very interesting and clear. So now it's time to question. So if you have any question or comments, please feel free to ask them in the chat, and we will try to answer them. Thank you. So let's start with the first question. So the forest you display in the presentation of your model for management simulation shows only monospecific pure conifer stands. What about mixed stands? Yes, stands with significant undergrowth, broad-leaved species, which are together the most common in Mediterranean forests.
Okay, I think the question is for me. Yes, so this was a demo version, so we focused on very simple plot. The Vallombrosa forest is a little bit more complicated than the one we showed, but we are also trying with different forests. And so, yeah, we are working on mixed forests. So we have different species inside the forest. So we are not just focusing on placing one model, even because it's not different. The workflow doesn't change. I mean, it is the same. So it depends on the species that are in a forest. If you have 10 species, we have the 3D models of each species. We can put them all in the forest, so it doesn't change. And we modify the parameters of each tree according to the data we give as an input to the system, which is a CSV file with all the information about each tree, such as position, height, crown dimension, diameter, dBH, and so on. So in the very moment we have all this information, we can replicate any kind of forest. At the moment, we are also focusing on the foliage, so all the leaves on the ground, because that can affect also the capability of the system to simulate the growth of other species. But this is the last point of the project. So the main point is that we have a digital twin, which is the the closest as possible to the real forest. And the workflow seems at the moment quite robust, and we don't have any specific problem replicating different type of forests in the Mediterranean. And starting from that, the idea is also to expand this simulation to any kind of forest in the world. I hope that this answers your question.
Thank you very much. We have a second question in the chat for Valerio. How do you rate VFDSS usability for day-to-day forest management decision, and what would you have to happen for VFDSS to be widely used?
Okay.
Ciao Valerio, I'm here.
Valerio,
also.
if you want, I can help you too.
You want to answer some?
Go Luigi, go
yes,
Luigi.
yes, I can help you to answer this question because this is an interesting perspective from Max, I think the names. So in our idea now we start with visualization of a stand, and also we try to combine the possibility with users, forest users, to simulate some harvesting scheme or some silvicultural operation inside a virtual environment. Then this ability could be used for a forester to simulate different harvesting operation inside the same environment on the same forest, and then to compare each other, because you can, as Valerio said, this visualization is combined also with the mathematical model that predict the growth of trees. And then this could be a support in application on of silvicultural operation in forests. So I think this would be a right answer for you.
Thank you. Yes, we have a question from Volodymyr Korzov. I don't know if he can. Yes.
Добрий день, шановні колеги. Володимир Коржов, Український науково-дослідний інститут гірського лісівництва. Це тут в Карпатах. Перше, я хочу подякувати за дуже цікаву інформацію і дуже, так би мовити, нову інформацію, особливо для нас, українських лісівників. І в мене є одночасно два запитання. Перше запитання. Йшла мова за масив лісу 180 тисяч гектарів. Інформація про нього. Мене цікавить, які види рубок застосовуються в тому лісовому масиві на півночі Італії. І друге питання, чи потім дати питання після відповіді?
Luigi, just maybe I need to specify that the 180,000 hectares of forest are in Spain, not in Italy.
Yes,
So,
they are in Spain. Yes, yes.
Yeah, the question relates to Italy or
Yes.
relates to Spain.
Or to,
Yeah.
to Spain, yes.
Які види рубок?
But I didn't understand the translation. Sorry.
Які види рубок застосовуються на цій території?
Okay, but
Види final
sorry.
cutting.
But I can't hear the translation. I'm just hearing in the original languages. And then
The same for me.
Luigi, they
Yes.
ask, hi, I'm Francesco Giannino from
Yes.
University of Naples. Luigi, the Volodymyr asked which type of harvesting, which method we use to
okay.
in our virtual, yeah.
Yes, so inside the virtual
Really?
forest, you can simulate every kind of silvicultural operation from selective cuttings or just thinning from below, thinning from the height with different solution. You can so it's open to to the application of different kind of silvicultural harvesting operation inside.
Yeah, I don't know if I can add something.
Я розумію, а які фактично види рубок використовуються на півночі Іспанії?
Sorry, can anyone translate?
Okay, in the north of Spain,
Okay.
English.
yes. In the north of Spain,
Yes.
they are clear cuts mostly in our area. They're
Yes.
like that's the most extended, but there's also forest clearings. Like there is first phase, second phase, third phase, fourth phase. There's a lot of forest clearings until we get like
How
to
much?
the first. Yes, sorry.
How much clear cut from all volume?
From the 3,000 auctions, 3,000 hectares of auctions, I could say maybe it's a difficult question, but I would say here in our region, in the Urbium model forest, more than 50%. Okay, more than 50% are clear cuts, but it's not normal in Spain. In Spain, there's other types of silvicultural things, but here in our area, there's a lot of clear cuts. It's quite intensive. Yep.
Дякую. І друге питання. Дуже цікава інформація про віртуальну модель лісу, але наскільки відомо, ліс складається не тільки з деревостану, але і мережі доріг, мережі волоків. Коли ви отримували дані про мережу лісових доріг і волоків, якими методами і коли були завершені отримання цих даних про лісотранспортну мережу?
I imagine that's a question for me.
Yes,
So
yes.
So the idea is that forest pathway is not the pathways as roads. Forest pathway is the silvicultural itinerary. That is what you need to do to reach a type of forest. Okay, you imagine that you have 1,200 stems per hectare, and these silvicultural itineraries give you the type of management that you need to do to reach, for example, 600 stems per hectare with a typical type of forest that you're going to have in that 600 stems per hectare. So it's kind of what needs to be done, how intensive needs to be the forest clearings in this case for you to reach that type of forest for a certain application. For example, if you want to use it for timber, really high quality timber, these silvicultural itineraries give you the type of management tips for you to have that type of output at the end of the day, like in the next 20 years when you do these silvicultural itineraries. Is it clear as I explain it this way?
And also about virtual forest use
Мене
for system.
цікавить початкова інформація, закладається. Є ліс, і в лісі є лісові дороги, і є трилювальні волоки. Значить, це в вашій програмі закладено, маючи цю інформацію про дороги і волоки, і маючи інформацію про деревостан, тоді можна приймати рішення логістичні для проведення лісозаготівлі. Мене цікавить, як формувалася інформація про мережу лісових доріг і волоків. Які методи застосовувалися для отримання цієї інформації?
Yes, I'm going to try explain it a little bit in another way. When I say pathway doesn't mean it's roads. Okay, when I say pathway, is silvicultural itinerary, like what you need to do in your forest for the forest to have a certain starting point and for the forest to end up in one point that you want to use the forest for. So we're not talking about roads. We don't have any information about roads or accessing point for the forest. We are using the name, the terminology forest pathway as a way of saying that you're going through a pathway, through a road to reach your objective. Is this clear?
I asked about road, forest road, and trail.
Forest road and, sorry?
Which presence in forest?
I don't understand. Sorry, Volodymyr. You said forest roads and what else?
Okay, trail. Not road. A road for forward, a road skidder. It is not a road. It's in Ukrainian road is road for trucks, trail for tractors.
Correct. Yeah. Yeah, I understand. But the tool that we explained doesn't talk about the roads. It talks about the way that we have one initial forest. Like the forest, as I said, could have 1,200 stems per hectare. That's the density. And the tool just focuses on the silvicultural part. It's just a silvicultural itinerary for you to get from one starting point at, for example, 2026 this year, and in 2030, in 4 years' time, you want to reach an objective. So it's called forest pathway in those terms. It's not in terms of it's talking about roads or having data about roads. We have other tools for that, but it doesn't comply here. Okay.
Understood. Thank you.
Thank you.
Okay. Maybe we can let's in another question in the chat. So, how are climate change projection integrated into your forest site tools to guide silvicultural choices in the medium and long term?
Okay, I can start answering the question, but maybe I will need the support from UNINA because at the moment climate change is not integrated into the system, mostly because I think that the mathematical model will be in charge of predicting the outcomes of climate change onto the forest. And I think it's quite difficult to predict the effects of the climate change and how it affects the growth of the forest. So it is not. We do not expect to put that right now in the project, but that could be a solution for the future. So the virtual forest decision support system can have a more complex, a more sophisticated mathematical model that can predict those outcomes, and then at the same time we can show that in virtual reality. So Francesco, correct me.
Yeah, thank you.
Yes,
Can add something, Valerio? Okay, I'm University of Naples, and we implemented the mathematical model inside virtual forest support system. Okay, now the input are you have some environmental data like temperature, okay, and we work a lot more on interaction of trees, like competition, light competition, resource competition. We can use real data to see the growth of the trees, or we can have some hypothesis of increasing temperature, decrease temperature for climate change, and we can use this input for our model really. Okay, there is no really a bottom like climate change. The idea that you can input your input data, environmental data, can be output from some climate model really, and can be input for our model. I don't know if I answered the question of Armeli. No, yeah, Armeli, I think so.
Yes, I think.
Let me add something about the second question. We have also in Valerio model in Mari group, they have already copies with many small stems.
yes.
we already have this, so we can also have a forest with this type of trees.
Yes.
Okay. We have another question. As the system provisions simulating responses to forest fire or extreme weather conditions like prolonged drought or tempests?
Okay, again, this is more a matter of what the mathematical model can do or it cannot do. Well, we are working also on another project where we can predict the spread of a fire. So if we put the fire in one spot, how it spreads across the forest. But the two simulations are pretty separate, so they are one far from the other. Because on one side we predict the growth of the forest just by the action you perform. So if you cut a tree, what happens to the other ones around, because they have more light, more space, and they can grow differently. And the fact that a fire spreads in a certain way is another simulation performed by another mathematical model. So they should be integrated to have the effect of a fire on the growth of the forest. But it's just the fact that we need a different mathematical model. As soon as we have one, the integration into the system is pretty simple. I mean, we still need to work on that, but the bases are good. And so we could also manage that type of behavior. But it's, as I said before, it's more up to the mathematical model to predict such behavior.
Francesco, could you please explain how inside the model we can regulate resources like water inside the environment, or like temperature? So this is because much people are interested in how disturbances like fire, like storm, or like drought could be used or simulated inside the model.
So we make this platform. So we have two different layers: the 3D forest, and we have mathematical model. Okay, and we can have a different mathematical model. We already make integration with two big model, one in forest growth in this project, and as Valerio told you, also one is forest fire simulator in the same environment. Okay, so we can apply different models. Okay, now, for example, for storm, we can use this in two different ways. You can have real data of storm, I don't know, and you can as input in our DigiMedFor, so you can see the whole tree and see the growth after this external input, or you can run a new model that make this, event and see what's happened after this event. So the idea is that we have a real modularity in this system. Okay, here we are speaking about DigiMedFor, so like forest and forest operations, agricultural operation, really. But in the future we can see that we can apply different modules, okay, and different mathematical models, really.
There is another question, Lucy, for Valerio, I think.
Yes. Yes.
Okay.
There is another question to Valerio. How long time does it take on average to create a digital twin with trees by trees inventory for 1 hectare of a medium age forest?
Okay, well, it's not a matter of how long it takes. It's more a matter of if we already have all we need, because we can collect data from internet regarding the landscape, the position, and the characteristics of the landscape. Then we need two more things. The first one is understanding which species are in the forest, because we have already modeled 37 or 38, I don't remember, well, almost 40 types of different species. And most of them are trees, but there are also bushes, so smaller plants. And also we need a very specific file, which is an CSV file. We already established a format with all the information regarding the trees in the forest. If we already have these, it can take a few hours to replicate a forest. So the tool is quite powerful. It doesn't take that much time. But if we don't have one species, for example, the workflow is it takes longer, because we need to model a preset of that species. And of course, later it would be useful because the model will be available for any other who wants to use it. But it's more a matter of if we already have all the information. And last one thing is that at the moment, we as Mare Group are creating the forest. So the tool is not open to everyone, because it's still a bit complicated to create everything and to make it a product that everyone can use. So it must be done in a Unreal Engine project, which is a software with which you can create video games, for example, which is the basis for the virtual reality development. We intend to create a tool in the forest where everyone can create their own forest, but that needs to have everything to create it in just 1 hour, 1 hour and a half. Otherwise, some customization work must be done.
Okay, thanks.
Thank you.
Valerie.
So if you have other questions, don't hesitate to ask in the chat. We have some comments. A comments is, so you really need in the short term to consider climate change impacts in your models, as they are based to a large extent on competition between trees, and climate change increases by far in this competition due to water stress in reducing also significantly trees growth and forest productivity at continental scale, and still similarly in most Mediterranean forests, and as double tree mortality in the next decades. Decades.
We agree with totally, and we will do in the future. So we are still doing, but we will do specifically. Okay, there is also some question that Antonio already answered. It's one related to the Courage platform.
Yes, do you want me to comment something? Yes. Maybe Max.
Yes.
Max also wants to open his microphone, or comment anything else, or if everything has been clear. Max was asking what the DKP, a little bit more information about the DKP.
Yes.
I placed the link to the platform, dkp.cesefor.xyz, if anyone wants to also have access to it. But I just explained a little brief summary that the DKP through the Forest Pathway tool is to take forestry models around Europe, thanks to the partners that have been working with us with CESEFOR in their local areas and their local documentation. And the idea is that we can tell a forest owner or a forest manager what kind of treatments are needed to achieve a harvesting objective for a forest in its initial state. For example, if you have a forest that does not currently provide you with a quality timber for sawing, these models will tell you what type of silvicultural actions, cutting, thinning, high or low, etc., you need to take in order to achieve your objective within a certain time frame. And after those silvicultural actions, mainly for the use of that timber. So it kind of tells you what to do to reach an objective of the timber that you want to use the timber for. And apart from that, I also mentioned that there is a Zenodot repository also linked in the DigiMedFor knowledge platform with the different data sets, which UNINA, THERF, all different partners around the project have been uploading with different data sets captured in different forests for people to also understand what are the latest technologies and what type of data they can capture. So it's also useful in those terms. I don't know if there's any questions related to this.
Yeah. I think there is no additional question. Okay.
No, we don't have any questions.
Okay.
Oh, I think Max is talking.
Well, I think Max is talking, but
I don't hear him.
I don't hear him.
It's Max is here.
Okay. Okay.
Does anyone hear him?
We can't hear you.
Want to hear him? No, I cannot see you.
No.
Now we can hear you.
Now we can hear you.
Oh yeah, I don't want and just want to add, Antonio, thank you. I looking forward to check it out because I think it's a huge challenge, and we have so much different models and so many informations. And yeah, we need to use something to need a platform to transport this to the practitioners, no, so that we can find the right tools for our questions. So, and yeah, we have huge information, and somehow we need to be more clear how we, the foresters, can use these to make better decisions. So thanks. I will look into it.
Okay. Any feedback that you want to tell us, we're more than open to receive it. Okay, so just write me an email whenever you have a time to take a look at it.
Thanks.
Okay, Luigi. I think
Yes,
for the moment there's no more questions.
That there is no more question. Lucy, if you want, we can.
Yes.
Yes.
So don't hesitate if there is other question, but I don't see any.
Okay. Yes, because anyone can reach us through website or social media. So we are open to your question, your curiosity. Okay. And then thanks for your time. Thanks for all the presenter, all the speaker today, and for people that hear this presentation. So I give you a good day. So have a nice day, and then we still working on this project. So thanks.